The next question says, in the circuit shown, lamp P is rated 250 volts, 50 watts, and lamp Q is rated 250 volts, 200 watts. The two lamps are connected in series to a 250 volt power supply. Okay, fine. Assume that the resistance of each lamp remains constant. So resistance of each lamp is not changing here. Which statement most accurately describe what happens when the switch is closed? So when the switch is closed, here's the dilemma. The power supply is supplying 250 volts, but each lamp to operate normally requires 250. This one also requires 250. So the question is, are they going to share, and how are they going to share that 250, which is less than what they would require? They would require individually 250 volts, but they're getting less than that. So the best way is to find their resistances first, to see if we are to do this one. The best way is to find the resistance first. If we are to find, because they say lamp P emits 4 times as much power as lamp Q, but this can also be dependent on the situation here. Is lamp P going to get more power? Is it going to get more power, and what is going to determine the voltage that it is going to get? Okay, so just to make it make work here, we have to determine what the voltages that they are going to have. But to do that one, then we must know the resistances first, the resistance of P and the resistance of Q. So we know that power is equal to V squared over R. So power of P is 50, and that's the normal power when there's a voltage of 250 volts. So when there's a voltage of 250 volts squared, then the power is 50. So what do I do? R therefore will be equal to 250 squared divided by 50. So that gives us 250 squared. 250 squared. Divided by 50. That will give us 1,250. That's the resistance of lamp P. What about resistance of lamp Q? For lamp Q, the power is 200. So we'll divide by 200 instead of by 50. So its resistance of this one of Q will be 312.5. The resistance of the other one was 1250. Anyway, knowing this resistance, if you check these values, you can see that the resistance of P is 4 times the resistance of Q. So the truth be told is that P, if it has 4 times the resistance, if P has 4 times the resistance, then as compared to Q, when they are sharing the 250 volts there, P will get 4/5 of the total voltage. Why does it get 450? Because the ratio of the resistance is 4:1. Is 4:1, so it will get 4/5. So 4/5 of 250, the voltage being supplied, that will be 200. So P will get 200 volts, and Q then will get 50 volts. So using that logic, now we want to know the power in this case. So power for P, power would then be the voltage, which is, we said that 200 squared, divided by its resistance, which is 1,250. So it would be 200 squared divided by 1250. This gives us 32. So that's the power dissipated by P. Then the power dissipated by Q would then be 50 squared divided by 312.5, the resistance of Q. So it's 50 squared divided by 312.5. This gives us 8. So the power dissipated here, it will be 8. So power dissipated by Q will be 8, whereas power dissipated by P will be 32. So P, as you can see, is dissipating 32, which is 4 times 8. So lamp P emits 4 times as much power as lamp Q. It was all by calculation.